The Magic Xroom, a flexible virtual reality platform for controlled emotion elicitation and recognition. The outline is context and motivation, virtual reality for affective computing, and the Magic Xroom itself in details. Context and motivation. Affective computing is a multidisciplinary field focusing on recognizing, interpreting, and responding to human emotions. Affective computing can enhance human-computer interaction systems. For example, sensing users' emotions and reacting to them improves users' experience. Emotions are complex physiological and psychological events, which are hard to elicit and hard to interpret. Affective computing faces various challenges, particularly related to emotion elicitation and emotion recognition. In emotion elicitation, the question is how to effectively elicit a target emotion. In emotion recognition, the question is how to effectively detect a person's emotion. These factors combined make it hard to collect high-quality datasets that can be used for research purposes, for example, development of emotion recognition algorithms. Virtual reality is a computer-generated, immersive, and realistic simulated environment users can interact with. Virtual reality has the potential for improving both emotion elicitation and emotion recognition. VR improves emotion elicitation by evoking a stronger and more genuine emotions, leveraging on multisensory experience, for example, audiovisual and haptic stimuli, immersivity, and high realism. VR improves emotion recognition by collecting multiple data modalities, like body movements, for example, joints and eyes, through VR headsets, and other signals, for example, physiological signals, using additional sensors. VR holds great potential for enhancing affective computing. Still, we don't know how to control emotion elicitation. How can we fully leverage the power of VR in affective computing? Let's exploit the theory of flow. The theory of flow links individuals' skill levels, task difficulty, and perceived emotions. In that, high skills and low challenge ends up to boredom. Also, low skills and high challenge ends up to anxiety. We propose the Magic Xroom, a virtual reality application for high-quality data collection. In that, emotion elicitation performed following the theory of flow. Also, extensive data collection performs using various sensing technologies. The Magic Xroom is an innovative and immersive standalone virtual reality application developed using the Unity game engine and the SteamVR framework. The main purpose of Magic Xroom is to improve the process of evoking and identifying emotions in a controlled setting. The Magic Xroom provides a controlled and consistent environment for conducting experiments and collecting data, in which different aspects of emotional reactions can be systematically investigated. The Magic Xroom engages users through sensory inputs and interactive tasks to elicit emotional responses. Following the theory of flow, task parameters, for example, difficulty levels, are dynamically adjusted based on users' skills. To reach this aim, users' skills are continuously monitored throughout the experience, enabling Magic Xroom to modify the virtual environment based on their performance. To accurately capture the emotion experienced by users, the Magic Xroom equips individuals with a comprehensive set of sensors that continuously collect diverse data throughout their interaction with the application. The sensors monitor physiological response such as heart rate, skin conductance, facial expressions, and eye tracking. The Magic Xroom currently supports the following sensing technologies: VR headsets and handheld controllers. Currently being developed compatibilities are eye trackers, face trackers, and galvanic skin response data by shimmer sensor. As a sample application, we introduced Tower of Hanoi. A variation of puzzles, Tower of Hanoi, has been created following mentioned methodology. The game consists of 3 rods and 3 discs, which can be slid onto any rod. The goal is to replicate the configuration at the top with the discs and rods at the bottom with limited moves and time. A tickling sound is played to induce a sense of urgency, becoming faster in the last few seconds. The user controls the disc with the VR controllers and moves them one at a time from one rod to another one. Tasks progress with increased difficulty either by increasing the complexity of the target configuration or by reducing the available time and/or moves. The goal is to induce anxiety in the user due to limited time available to think of a solution paired with a limited movement, leading to 1 or 2 maximum set of possible moves to solve the puzzle.